Do you foresee adding library features to avoid allocating an array for each step of a map chain? Haskell is lazy evaluated, Clojure has transducers, Rust has iterators, etc. Mostly I think just go back to the old procedural style rather than all the added complexity. Yeah, I don't, this is not a functional programming language in that sense, and it's not really, that's not really the style that I think you program in when you want to go fast, right? That's a style that you program in when you want to like do quick and dirty stuff. Like you're just playing around with some gameplay code to see if you want something to be that way, or you know, I'm just mocking up some tools that may or may not later become our in-house production tools, right? When they become our in-house production tools, we'll do another pass over the code to make it more serious, maybe, right? So it's, in my mind, it's for that kind of thing. It's for when you want to do stuff quickly and don't want to care about implementation details. Now that said, we already have plenty of features. Like if you wanted to do that map and wanted it to be relatively fast, then you know you can always replace the allocator with a stack allocator, right? And then you know you're not allocating anything on the heap or anything, right? So we demoed that a long time ago about how you can do that for just localized regions of code, right? Because the allocator is a variable that's stored in the context record, which is the whole thing that we spent a whole demo on. So you can poke in a new allocator just for one particular subtree of your code, or you know, call graph of your code. So that'll help. But as always, if you really want to go fast, then I think you care about the data yourself, right? Like as Mike Acton would say, if you're transforming the data, that's what has to go fast. So adding abstractions to make you not think about the data that you're trying to transform quickly is never really going to get you that fast, I don't think. Someone's asking, have you thought about your language at all for embedded systems, or even gone so far as to thinking that it would be a good place for it? I have thought about it a little bit. I don't have a lot of embedded systems experience, but I've, you know, some of the features that have gone in with thought about embedded systems in mind. So we'll see. You know, we'll see how that plays out. Someone's asking, are there any interactions between the Lambda feature and the capturing feature that exists, question mark. We don't capture yet. So going back to here, you know, when I do something like this, so this is not capturing any variables from the outer scope. And if you try to, it'll give you an error right now. It'll say, you know, Lambdas can't capture yet. They will be able to. It's just it's lower on the implementation priority list than certainly than basic Lambdas, right? So the thing about capturing in C++ is that it's kind of a mess because it means your Lambdas are a variable size and are a different type than your regular function pointer and all that stuff. I don't think that any of that has to be true here. Like, one reason why I was procrastinating on that compared to other things is just because I didn't necessarily know the right answer yet. But I think I know the right answer now. I think I completely know the right answer. However, the way I will probably mock up Lambda capture at first is in user code. You know, you would enable people to build like a functor or whatever wrong term they used in C++ to name things. Which is basically, in C++, what they call a functor is just a data structure that you can call as if you could call a function. So it supports operator parentheses, which is a thing that I haven't done here. Like I did operator overloading last time, but you can't overload function call yet. So I'm probably going to do that and make that work from user code. And then once I'm satisfied with everything about how that works, then we'll probably make it a compiler built in eventually to capture things. I don't think it's a problem. I think the groundwork's all been laid for it to be very, very clean. Especially, you know, there are certain things you can do with the calling convention that massively simplify any kind of problem that you have in the C++ world with this. So I'll be happy to do it. It's just we haven't done it yet. None of the code bases I'm working on right now really use lambdas with capture. There is one project that I was doing a bunch of stuff in with lambdas with capture, and that's actually a real game. It was a side project that I had while working on the witness. I use a bunch of lambdas to good effect. So maybe I'll try porting some of the code from that as a test case. Do I plan to show the polymorph solver iterations in compiler errors? Maybe. I mean, there could be a compile time flag that just, instead of just dumping all that out, maybe it saves it to a buffer, and then if there's an error, it gives you the most recent one. But usually I think you shouldn't need it, because this stuff shouldn't be complicated. Like if you get to some situation like Nightmare here, that's just bad code, right? Now the thing about map is the reason I liked it is it's totally obvious to the programmer what should be happening, right? Like, look, we've just got some guys in an array, and so obviously we want getName to map from a guy to a result, right? Duh. Like, so that's the problem is that the compiler in C++ can't do this, right? That's the issue. Or let's go to the nicer syntax. The compiler in C++ can't do this, right? That looks simple, but it can't do it. So that's sort of the main reason why I went and did a more powerful solver. However, when you're trying to figure out a problem in your code, you always want as much information as possible. And so, yeah, we'll see. We'll see if it makes sense to provide that information. Someone's asking about testing. I am not a unit test person, so I don't even know what... I don't like the idea of unit testing very much. I mean, it's fine as long as the scope of what you're building is very small. You can't really unit test the hard parts of a game. You can only unit test the easy parts. So unit testing, to me, does not solve any of the hard problems. Regular testing, yes. Like, I'm a big believer in just testing. But testing and unit testing are not the same thing. Like, you should test the hell out of things. Like, let's not have any ambiguity there. So LKey144 has again got his question, and I'm not sure I understand the question. So you're saying, without the lambda syntax, the boilerplate associated with writing normal functions could become quite extensive without being able to declare and infer everything. Maybe. I don't know. I don't feel like it's been a problem so far. To me, really, this is more about just convenience and nicety than it is that things are impossible to do in the long form like this, right? But we'll see. Basically, I saw people doing that in C#, and I was like, oh, that's neat. Let's do that. If I redefine do it as polymorphic, would all the polymorphic matching still work? Yes, it would. I mean, that's basically what map is, right? I mean, map is just like do it, except on multiple items. So all that would be fine. I mean, the question was, if you don't remember what that was, it was just this. In fact, I believe, well, I mean, if I make all this polymorphic, then well, let's find out. So let's say that's a T, F maps T to T, and then is there any other reason? I don't know. I feel like I forget something. Nope, it worked. So the do it still works. Let's make sure it's, just make sure that it's recompiled. So yeah, because you know, again, the 11 gives us T right away, and then so when you match square poly, int comes down from, well, it's not exactly how it works, but this T sees int here and grabs it, right? That's basically what happens. Someone is asking, with respect to the problem with type matching A with R currently, the notation $ is used in polymorphic functions whether or not the types are free, as in free variables. Would using two notations help? Well, I don't think so, because when you say whether or not they're free, if I understand what you're saying, let's go back to Nightmare. If I understand what you're saying, then you mean like, well, when I define Nightmare, I would know that certain parameters are not going to be matched immediately, but you don't necessarily know that, because people could call the function in different ways. Like some procedures might be polymorphic as parameters, some might not. You don't exactly know. And so at declaration time, I don't think of it as like I know what the free parameters are and what aren't. I think of it as I know what this procedure needs in order to function, and everything else is a variable because that makes it maximally generic, right? Something like that. I don't know. It's possible I misunderstood the question, though. Someone banned type theory. Oh, maybe not. Maybe he's not joking. I don't know. I feel like type theory is the guy who like always heckles me on YouTube or whatever, but is there any runtime overhead for what I've shown today? No. This is all compile time operations. What is the error message like when you pass a struct to the getName procedure, but the struct doesn't have a name field? Seems likely to be complicated. That's a good question. Let's try it. It used to be a good error message, but I think I might have broken it because, you know, I changed a lot of stuff with the loop solver. So let's just say a whatever is a struct, and it has an F. It doesn't have a name. It has an integer, right? Okay. So then we'll go to our first getName example. Let's just call getName. We're going to say a W is a whatever. Oh, we don't have a getName yet. Here we have a getName. So W is a whatever. Oh no, we need a polymorphic getName. Let's go to this one. This is about as polymorphic as you can get, right? So W is a whatever. Print get name of whatever is get name of W. So that should blow up. Yeah. So this is a very unhelpful. Wow. I don't know. I don't know why that happened. This is essentially, yeah, this is new. This is the most unhelpful error message that you could possibly get. So I'm going to have to work on that. Error messages in these cases are very, very important. And I feel like compilers have not prioritized them nearly enough. Because I just revamped all this code And I just got that done today. I haven't gone on to making the messages nice, but we will do that. Yeah, this is so unhelpful that you don't even know what line the error message is in, because it gave you just an error in main. And it gave you an error that doesn't make sense to anybody but me. So that is interesting, though. I wonder why. I'll have to take a look. I don't know why it's doing that. It's a little bit of a bug, because at the very least you should get a user-facing error message, not a compiler-author-facing error message. When do I plan to release a compiler? When it's ready. When stuff like this doesn't happen, and when all the features are done. Usually I'm much better about stuff like this, but I'm trying to do demos faster because I had a big gap when I wasn't demoing for a while. You know, we need to get done with all the features. We're getting toward the end of the features. Like, the features we're doing are getting smaller. So we'll get there. We'll converge eventually. Will this be feasible for beginner programmers? Well, it's going to be simpler and easier to deal with than C++. So if someone's teaching you C++, then and you can handle that, you can handle this. Do I find myself wanting the ability to map a function frequently while making games? It depends on the game. In the Witness, I didn't necessarily. There's rare occasions when you do. In other kinds of games, I did a lot, actually, as I mentioned earlier in the stream. In your getName function with return type of xName, let's go to that. So this one, for example, is the type of yielding an object type or a reference? Is the function returning a reference to the name or a copy of the name? I see. So you're thinking about this in a C++ way. So we don't have explicit reference semantics at this time in this language. And I would like to get away from that, because that's what introduces some of the complexity in template stuff in C++. Instead, the calling convention is just different. So the calling convention of return values So let's just substitute this right away. So type of guy.name is string, right? So let's just say this for a second, right? So we're returning a string. A string in this language is not the same as a string in C++, right? It's a data pointer plus a length value. So it's bigger. And so the question is, well, do you return a reference to it or not? If you returned this by reference, it would be gone as soon as the stack was gone, right? So that would not be very useful. The calling convention in this language so far, which I think is going to stick, is that the caller allocates the space for return values, and then essentially from there it's the same as like an out parameter, so-called. So you get an invisible pointer to this thing, and then this procedure puts the data into that pointer. So in this case, that would be a copy. But if you were just setting the return value, I mean, you can optimize the copy away in certain cases. Like if you were just making a new thing on the stack and initializing it and then putting that into the return value by returning it, you could just optimize out the temporary copy and put it directly into the memory, right? So it makes it a good way to return large values in some cases. But we have to see. That's just my my first guess at how that calling convention is going to work. So if I understood the question, this is just a return by value, but its return by values are different than what they are in C++. And the polymorphism in this case just, I think, obscures the issue. If I understood the question, maybe I didn't. Any plans for closures with the lambdas? Yes, I just talked about that. Maybe you typed the question before I talked about it. Do you plan to deduce return types? Currently, I don't. Except for in cases where it happens, you know, like in this nightmare case. You know, here's a, well, I mean, this is deduced off of that, right? So there's no like auto here. I'm just not sure if I like that. It's kind of ambiguous, right? Because, and I'm not sure what's a good answer, because you can have multiple returns from your procedure, and they could actually return multiple different types, because, you know, you could return one thing that implicitly converts to something else, and you would maybe have to do some analysis on that to figure out what the most specific type is or something. Like, I don't know if that's the kind of business I want to be in. Like, I don't want to be in the functional language kind of business of inferring everything all the time, because I want to stay in a zone where the programmer has a high morale about knowing what's going on. And so I kind of don't mind erring on the side of you saying the type a little bit, because, I mean, you know, so I demoed this crazy solver of this crazy situation, and it's fine. You should be able to do that, but you shouldn't do that, right? So I don't want programming that I do every day to be like nuts like this, right? I want it to be grounded. So that's why I just haven't, I'm not seriously thinking of auto return type as a feature, but if it's necessary to do some important functionality, I will think about it. What is going on? My chat is just scrolling. Wow, someone's saying, you might be interested in this blog post about Swift's type checker, which is so slow it bails out on some trivial expressions. That's weird. Due to speed? That's weird. I don't get it. Okay, I might be missing some question. I don't, let me just scroll down to the bottom of chat. Like, what even is, no, it's just really legit conversation. Okay. Just, I was like, is someone spamming chat? Like, what's happening? Okay. Well, I have an object literal syntax for this language like JavaScript. This language doesn't really have a concept of objects. If you mean struct literals, we'll do struct literals approximately the way C++ does, or something like that, unless someone tells me something better. If you have ideas for something that are better, this is a good time to do the address. You can email me here. This is not a mailing list. It just goes to me. I don't reply to most things, but I do read everything. So you can email any ideas that you have. I'm just busy with so much stuff going on. I just can't have protracted email conversations all the time. But yeah, I mean, we'll have struct literals, which I don't think I do struct literals yet. You just can do array of scalar literals so far. Like that, you know. Because, you know, literals have just been lower on the priority list. So even this is a little bit of a cumbersome syntax, or it's a little weird. This is just like what I did to make this work. It'll change. Do I plan on having a good debugger? Yes, a good debugger is important. We'll at least demo some steps toward that eventually. Someone's saying a cool exercise that would grab more C++ programmer interest is if you made equivalents of the algorithms of the algorithm header and compared and contrasted the code, maybe. But, I mean, that might be a nice exercise. I've just got more important things to do right now. Like I'm trying to build the compiler and push some real code to make sure that things are reality-based and working well. So, you know, stuff like demos just to show how cool features are. I mean, it's fine to do this like feature reveal demo or whatever. And the way that I kind of motivate getting these features done is by scheduling a demo, and then I've got to get all the work done by that date that I've announced. You know, spending more time on it than that, I don't think is good for me right now. So someone's saying a comma b, so the lambda syntax, a comma b yielding compare strings of a.name is equal to type of compare strings a.name, b.name, but it doesn't seem like you can type that right now. You can, I believe. Let me go back, let me get rid of the whatever horrible compiler error, right? So let's go to main. Let's make sure this runs again. All right. The last thing in main I'm going to do. So first, let's just make two strings. S1 is hello. And you know what S2 is. It's sailor, right? And result is, let's just call compare strings for a second. Right. So minus 11, which I believe is the difference between H and S, right? Is that true? Yes. So, you know, hello is less than sailor according to this string comparison, right? So now the type of result type of, I believe this will work, right? If I just say type of compare strings S1, S2. Yes. So print result type is result type. It's S64. Ta-da! So yeah, I don't know where to go from that aside from that that's the answer to the question. Do I think generated lambda types would be introspectable via reflection so you could observe, capture data in a debug tool? It already is. So if you go back to the demo type info or whatever it's called, you know, I do that demo where I show that every type that the program knows about is iteratable, right, and has metadata. That is already true for any procedures that get generated from polymorphism. Or, so that covers all lambdas right now, but then eventually when lambdas capture, that also will be a new type that will be introspectable there. So yes, you'll be able to see all that stuff. Would I consider allowing procedure declarations to omit the types of their parameters if they don't use said types? Similar to lambdas being generic by default? I don't know. I mean, again, that sounds like becoming a little too ungrounded. I'm being wary when I go into polymorphism, because I don't want programming to be like, well, I just type a bunch of stuff and hope that the compiler can figure out what types things are, because I don't know, right? I want you to know what types things are. Unless you're doing something that really is polymorphic, right? I don't want this to just be like, well, I'm just letting you be lazy and not understand your program. Because I don't think good programmers want that. The kind of good programmers that I know don't want that, for sure. And I don't want that. So how does type of work on a function with multiple return values? It'll just tell you the, well, on the function, it'll give you back the function type, right? But if you mean calling the function with multiple return values, it'll just, and anytime you have a function call in a context, in an expression context, and you pass it to something else, it's just like saying, let's say 2val is some function with 2 return values. It's just like saying what happens if you call f of 2val, where f is some other function. You just get the first value. The later values are considered to be additional information. So type of would give you the type of the first value. In the case of Nightmare, do you plan on adding a warning of some kind? Basically saying, whoa, dude, you technically can do that, man, oh man. Maybe. I mean, maybe we can set a cap on the number of iterations that's reasonable and generate a warning if it's more, but I'd rather leave that up to the user. Maybe there's a way that you can program that. Why not use line numbers instead of the greater thans? I don't know what that refers to. This is my Emacs config. Why does everyone ask me about my Emacs config? Just like take a screenshot and pluck the colors out and set those. Someone's saying they like the language. Thank you. I like it too. Would I ever consider restricting access to Struct members for things where the Struct member is bookkeeping? I would consider it. In fact, there's probably going to be a set of features that goes in that relates to that. But I certainly wouldn't make it the default like it is in C++, right? Like if you make a class. That whole like, hey, you're supposed to hide your data members, I don't think is really right most of the time. Not in my experience. But there are cases in which you do want to do that. So yes, that will probably happen in some way. Would the generator, that's the same question I already answered. When I'm developing language, are there any techniques that I use to keep organized? Do I keep a big list of bugs? Not really. I mean, I have some to-do list files, but really I'm just sort of working on things in the order that I feel like it. Like I even ignore the things in my to-do list a lot of the time. But right now also, I mean, I'm working on, in addition to the compiler, I'm working on a program in the language. And, you know, that, like, the reason why I went and did operator overloading last week is because I needed, or I sort of was feeling the pain of not having operator overloading and decided to come do it, right? So that's driving a lot of things rather than a list. Like just software production is driving a lot of things. No, I have not added inheritance. Can you get the second return values type without overhead right now? I assume you mean without invoking any runtime operations. You could. I mean, it would have to be known, right? So you can do arbitrary stuff. So, like, I could make a procedure called tell me the second return value, right? And what it would do is you know, basically it would look at the type info. If you go back and look at the type info demos, you can get a runtime type record. Now I'm saying runtime, but we'll change that in a second. You can get the runtime type record for that procedure. You can look up how many arguments it has, and you can pull out the type of the second argument. Like that's just a thing that you can do. And you could do that at runtime, which is even more crazy than compile time, right? If you're used to these languages, it's more crazy. Now to do that at compile time, you just run that runtime procedure at compile time. So at worst, once you define this, you could say hash run, tell me the second return value of blah, and you would get that. And dependencies already work here. So this run would not run until this was resolved, right? So yeah, that's how you would do that. I don't want to try and write that procedure right now. Now the question is there a way, without you going all the way out to userland and writing your own thing, is there a shorthand way to do it right now? I don't know the answer to that. There might be. Oh, well, no, couldn't you do this? Let me just try this. Okay. toval, takes no arguments, and returns int and string, right? And we're just going to return 42 hello sailor. All right, so that's our two return value thing. We're going to say second, I don't know what to call this. We'll call it figure it, takes a procedure type A to B, right, returns a type, return B, right? So first of all, let's run this at runtime. Print figure it is this, figure it toval. I think that should work, right? Procedure call is missing argument 2. Oh. Right, it thought that this was a second argument to that. All right, so figure it is string. So at runtime, right, I didn't have to go define my own thing, right? I'm just saying, look, okay, we're returning a type, it's B, so the polymorphism match gets the value of B at compile time. Now there is overhead so far, right? But I can do this. I can say T figured colon, so it's constant, right? This means it's not a runtime value, it's a compile time value. Run figure it toval. There's a small chance this might blow up, because like I said, I've been changing the polymorphism a lot, and we're way off script at this point. But this should be the same thing with no overhead. Oh, okay. The problem is run directives only handle register size things, right, or 64-bit things right now, and a string is just a bigger thing. So if I swap this is dumb, but this should work. And this is just like, you know, some of these features could use more work. No, that didn't work. Invalid type of return value from compile time code execution. Return value must be something the compiler can translate. Oh, it's because it's a type. Yeah. Oh, yeah. Okay. This is the problem. This is not at all what I just said. Let me undo that change. The problem is, and this is maybe an implementation detail, is the way that run works is it runs a procedure and then basically cuts this part out of the code and puts whatever the result was, right? So if it's an integer, or I think I actually do handle strings and I forgot, right? But let's say it's an integer, it essentially puts the integer there and then compiles your program, right? The problem is that I can't pass a type from compile time to runtime, because it's not really, like, a type is a pointer sort of to a record. It doesn't have to be, right? But right now it's like at compile time it's a dynamically heap allocated pointer that doesn't have a meaning at runtime, and so it's saying like I can't I can't translate it into a literal. So I guess this should go on the to-do list of like, well, types should be translatable into literals in some way. I just don't know what that way would be. It's a mystery to me. If you have an idea, send it to the email address. Now you could in principle, you don't, the only reason we're trying to pass this, the only reason we're trying to pass it to runtime is so that we can print it. If you only wanted to use it at compile time, in principle, you could do what I just said. But in practice, it still insists on binding it into the program, so it wouldn't work. So if we wanted that to work, I would have to make the compiler understand that. One second. Anyway, that's a definite to-do list item. But I'm not sure, it's one of those things where I'm not sure what the right answer is yet, and those tend to be the things I procrastinate on. Can I explain why figureIt has runtime over? Well, it's just if you run it at runtime, then it's a runtime function, right? So when I did this, well, if you did like this, right? Okay, well, I mean, I did all that crazy stuff with run, but if you did this, then it should in principle have no runtime overhead, right? The thing is that yeah, I mean, this would have no runtime overhead, but you only have access to the type at runtime, right? So this would compile into, if I just put string here, right? However, a different problem is, well, I want to use that type at compile time to do something else with it. And sort of what I just demoed by that other thing blowing up is that the compiler cannot quite do that yet. It's a little corner case in the functionality that I don't know what the right answer is. Could I remind you what I think of methods? I don't. So a type as a value, it's just a type, man. You know. It's just a type. So it is kind of great that we can actually run this at runtime, right? I mean, so all that happens is at compile time, A gets bound to int and B gets bound to string, right? So A and B are sort of like constants living in this procedure. You know, this is interesting, though, because the types are successfully, the types that are bound to A and B are successfully surviving to runtime, right? Because I'm returning the string type here. So really, the whole thing that I just said about it being a problem to pass it from compile time to runtime is not as hard as I said it was, because I've already solved it, right? Because these are types that happen at compile time, and they get stashed away in the constant. There's a special namespace for each procedure where the template variable solutions go. So that got stashed away there, and obviously that has survived into the compiled program. Otherwise, this would be garbage. So I just need to do the same thing for things that are stored in variables at regular scope. So it's actually not that hard of a problem, I guess. I just, you know, I have so many things I'm working on. I forget. As you saw, I forgot even what the point of part of my demo was in the middle of the demo. So when I'm forgetting things like that, it's easy to forget details like this. But yeah. Yes, so figureIt compiles down. So if you compile this, right, and you pass it to val, then it basically just compiles into, you know, this, right? This becomes this, and because this is inlined, then, you know, you should just have string here. Have I ever thought about devising a development library to ship with the language? I don't know what SFML is. There will be lots of useful code and stuff that ships with this. That is the plan. All right, thanks everybody. I'm going to go have some fun tonight. Thanks for showing up and watching the demo, and I will let you know when the next demo is. I think it'll be pretty soon, again, because there's some functionality. It'll be a smaller demo again, but there's some functionality in the backlog that we haven't shown. So, you know, maybe in a week or so we'll do another one, make up for that big gap when we didn't do any. Would there be any value in type of being able to get the return type of function? Maybe. Yeah, I mean, if people need it a lot, you could make a keyword for it or something. Bye, everybody. Thanks, Abner, for moderating. I didn't see if you banned anybody. We'll see you hopefully next week. I'll announce as soon as I know when it's going to be. I will do the announcement.